tiny comet just did something astronomers have never seen before. It slowed down, nearly stopped, and then started spinning the other way. Not because it hit something, not because a planet pulled it apart, because sunlight was tearing gas out of it like tiny thrusters, and over time, those jets were strong enough to reverse the spin of the entire comet. The object is called 41P. It likely came from the Kuiper belt, gets pulled through the inner solar system every 5.4 years, and this time it revealed something extraordinary, and it is not some giant monster from the outer dark. It is tiny, only about 0.6 of a mile across, small enough that forces which would barely matter on a larger comet can completely change its behavior. That is what makes this so wild. Comets look massive when they light up in the sky, but many of them are fragile little bodies. Dirty ice, rock, dust, weak gravity, weak structure. When one gets close to the sun, frozen material begins to vaporize and blast off the surface. Usually that creates a tail. Here, it changed the comet itself. Back in 2017, astronomers saw 41P's rotation slow down dramatically as it moved through the inner solar system. Then Hubble followed up later and found something even stranger. By December, the comet was rotating much faster again, with the simplest explanation being that it had continued slowing until it almost stopped, and then the same uneven outgassing had forced it into a near opposite spin. That had never been observed in a comet before, and the reason it happened may come down to one brutal fact. 41P is small, really small. A larger comet has more mass, more resistance, more stability, but a nucleus this tiny is easier to twist, easier to torque, easier to push around. If the gas jets are lopsided, they do not just make the comet active, they can control it. NASA compares it to pushing a merry-go-round. Push against the spin long enough, and you can slow it down. Keep pushing, and eventually it starts turning the other way. That is essentially what happened here. And that matters for a much bigger reason than one weird rotation record. Because this is a glimpse of how comets live, change, and die. 41P was far more active back in 2001. By 2017, its gas production had dropped by about an order of magnitude. That suggests the surface is evolving fast. Maybe volatile material is being used up. Maybe dust is sealing parts of the surface. Maybe the comet is simply wearing down. Either way, this thing is not stable. Models in the study suggest that continued spin changes could eventually make the nucleus structurally unstable. And when a comet spins too fast, weak gravity and weak material strength may not be enough to hold it together. In plain English, it can start to break apart. One of the researchers put it even more bluntly. He expects this nucleus will very quickly self-destruct. So this is not just a story about a comet reversing direction. It is a story about a tiny object being pushed around by sunlight so violently that it may be heading toward its own collapse. A frozen body from the early solar system, only a kilometer wide, getting twisted, weakened, and rewritten in real time. And the craziest part is that it did something no comet had ever clearly done before, right before it may destroy itself.